Okay, so first of all, I'd like to introduce Tarrant. He is one of my colleagues. He works as a load and haul engineer in the company that I work in. It's a large iron ore producer. The role that we're in is basically focused on providing inputs into the planning processes and using the best data that we can. He specifically within the teams is basically tasked with a lot of the data processing and validation. He's the guru when it comes to all the programming and the most involved with the work that we carry out in terms of machine learning and digital twin, all that fun stuff. And that's why I'll be asking him these questions. So first of all, thank you for making it, Tarrant.
You're welcome.
I guess the first question, pretty straightforward initial one. In your own words, can you describe what digital twin technology is?
I guess it's mainly about gathering and storing data in a way to try and represent something physical. The data is generally gathered from a bunch of different sources or harvesters. And then from there, there's a certain amount of, I guess, machine learning or manipulation that happens on it to try and understand exactly what's happening from the physical world, but in the digital space. It's not necessarily a new concept or anything, but it is something that's becoming more relevant with the amount of, I guess, new sources we have available and just the way that the industries are sort of developing. It's happening much more quicker, and there's a larger focus on the, I guess, digital world as it may be, even though it's still all the same physical phenomenons going on.
Perfect. And I guess for the sake of providing a practical example of the application, for the truck data that we're seeing coming out of the mine sites, for example, what kind of sensors do you reckon provide inputs that we get to use for the creation of digital twin models?
So right now we're mainly looking at positional data for these trucks, which would be, I guess, the latitude and longitude of the truck at a specific, at a given time. And from that, and using a bunch of other, I guess, tags of truck type and other pieces of metadata involved, we can try and understand how these trucks are actually running and behaving across the various networks.
So I guess this question focusing more on the implementation and the direction it's going. Do you think the platforms that we use right now to implement these digital twins are mature enough? And do you think we have room to grow further in that space?
There's definitely a lot of room to grow. Even though we are seeing a lot more availability of these sources than we used to, it's still only a small portion of what might be available in the future. Not only the amount of sources that might be available, but just the accuracy of those sources, the amount of gaps we're still seeing in these sources. It's still a bit of a hindrance on how this data can be used to create a simulation of the physical environment. So it's definitely a lot of options available going into the future to try and, I guess, grow these concepts and make it a bit more robust.
And I guess one question particularly focused on the current applications. Do you see situations where we've attempted implementation of something like this that hasn't gone too well? And I guess in a way that can be improved going forward?
I think one thing people tend to try and do as soon as they see the opportunities of something like digital twins is to try and boil the ocean. They try to solve all the problems at once, starting from a very high level, whereas it tends to be much easier to actually get anything implemented or fixed if you start with much smaller bite-sized pieces that can actually be tackled. There's been a number of implementations that have failed because of, I guess, the higher level thinking driving the uses for these technologies at the moment.
Awesome, thanks for that. I guess the next question is, what technologies are needed to create a digital twin? And I guess in this case we can be specific to the applications we've seen within the company.
I guess the first thing you need is to be able to ingest the data, because generally it's presented in just loose file structure or loose log files. So first there needs to be a way to actually understand what that data means or is trying to represent. And then from there, once you've actually understood it and ingested it, then the next thing you'll need is, I guess, the bulk data storage. Generally, with all of these data sources and the amount of data that you actually need in order to do proper machine learning, it takes up a lot of space to actually try and store this data. So yeah, but bulk storage is the thing that'll be required. From there, once you've, I guess, ingested it and stored it, the next step is to try and, I guess, after you've manipulated it with the machine learning algorithms, try and actually display the data the way that we're currently doing it. With the twin that we use that's been developed by Petra is to access it on a SaaS basis.
Excellent, thanks for that. And what would you say the biggest challenges are for digital twin technology as we move forward?
I guess, as I just talked about, the amount of volume that comes through from some of these sources is quite immense. So there is always going to be this challenge of trying to stay ahead of the amount of data that's coming through, especially as more applications are found and more data needs to be stored. Along with that, the actual consistency of these sources of data sort of starts coming into question once you start running analyses. You can see gaps in the data. You can see anomalies in the data is the word I was looking for. You can start to see gaps and anomalies in the data coming through. So these are just things that it's pretty inherent right now in our current state with the sources and the types of data we've got. So it's just something that needs to be accounted for. But I think it certainly is a challenge, and probably will be going forward also, to try and understand the data properly so you can actually account for these various gaps and anomalies when they do happen. Along with that, not all applications are going to be viable, and so some of these points of viability might be based on the gaps and the anomalies coming through, because they might be a hindrance on certain things you're trying to look at or analyze. But yeah, and other reasons that other points of non-viability for certain analysis might be just because of the amount of manipulation, calculation, parsing you need to do on this data. Once again, coming back to the just the amount of different pieces of data coming through.
And I guess with all that really good context, would you say your experience so far with this technology is positive? And I guess would you say there's functional applications even outside of the mining industry and just generally in other environments where they can collect the volumes of data required to support something like this?
Yeah, there's definitely a lot of value inside and outside of the mining industry. I guess once you've captured the data digitally, it doesn't necessarily matter what the industry looked like prior to that data or where it's coming from. There's certainly a lot of value in understanding data regardless of what industry you're part of. I'm sure there's plenty of things that the aviation industry, for example, could try and get from something like running digital twin technologies if they're not already, and just doing simulations on various pieces of data and different outcomes, or the way that different pieces of data are reacting to different aspects of the environment, and trying to understand and optimize for those different pieces of variability.
Fantastic. Thank you very much for your time.